One little black spot on the sun sure can cause a lot of fuss. Twice every 120 years, Venus passes directly in front of the sun. The circular spot the planet makes on the solar disk is not much bigger than an ordinary sunspot. But every time it happens, it is a worldwide sensation. The next transit of Venus is on June 5, 2012. And for the first time since the 19th century, the event will be visible across all of North America. The nearly 7-hour transit begins at 3:09 p.m. Pacific Daylight Time. Observers on 7 continents, even a sliver of Antarctica, will be able to see it. Across the United States, the transit is at its best around sunset, a rare photo op for creative photographers. Observing tip: do not stare at the sun. Venus covers too little of the solar disk to block the blinding glare. Instead, use some type of protection technique or solar filter. A number 14 welder's glass is a good choice. For some observers, the view provides an unsettling sense of scale. Venus seems so small and fragile against the solar disk. Our own planet is equally minuscule. Others say it looks like a black hole punched in the surface of the sun. Very strange. Transits of Venus first gained worldwide attention in the 18th century, when one of the biggest mysteries of science was the size of the solar system. It might seem amazing today, but astronomers didn't know the absolute distance between any two planets. How many miles would you have to travel to reach another world? The answer was as mysterious then as the nature of dark energy is now. Venus was the key, according to astronomer Sir Edmund Halley. He realized that by observing transits from widely spaced locations on Earth, it should be possible to triangulate the distance to Venus. The idea galvanized scientists, who set off on expeditions around the world to view a pair of transits in the 1760s. The great explorer James Cook himself was dispatched to observe one from Tahiti, a place as alien to 18th century Europeans as the Moon or Mars. Historians have called the international effort the Apollo program of the 18th century. In retrospect, it falls into the category of things that only sounded like a good idea. Bad weather, primitive optics, and the natural fuzziness of Venus's atmosphere prevented observers from gathering the data they needed. The distance to Venus was not measured with high precision until 2 centuries later, when astronomers of the 1960s pinged the planet with radar. This year's transit is the second of an 8-year pair. Anticipation was high in June 2004 as Venus approached the Sun. No one alive at the time had seen a transit of Venus with their own eyes, and the hand-drawn sketches and grainy photos of the previous centuries scarcely prepared them for what was about to happen. Modern solar telescopes captured an unprecedented view of Venus's atmosphere, backlit by solar fire. They saw Venus transiting the Sun's ghostly corona and gliding past magnetic filaments big enough to swallow the whole planet. One photographer even caught a spaceship, the International Space Station, transiting the Sun alongside Venus. 2012 should be even better, as cameras and solar telescopes have improved. Moreover, NASA's Solar Dynamics Observatory is going to be watching too. SDO will produce Hubble-quality images of this rare event. Apparently, one little black dot really is worth all the fuss.